Yeah, definitely a super mild winter. I agreed. Up here in the state of Colorado, we are having a bit of issues because we had 12 to 14 inches of snow in the mountains, and in the plains, we had a red flag high fire danger warning going on because of high winds and super dry conditions. So, keeping us on our toes in both directions. All right. Well, it's 8 o'clock. Thank you everybody for being here this morning. Truly appreciate it. Uh, Today we're going to talk about daylighting, daylighting requirements out of the energy code, and how it works, what we do with it, and is it as much fun as it sounds like? If you're a code geek, daylighting's probably at the top five of your list for fun. And I do apologize. My mouse and I are not working well together today, so it may take a second to get between the slides. Um, Other than that, we're good to go. Introduce myself. I'm Troy Jones. I work with Shums Coda. We're here with the help of Excel to get these classes up and running for you folks. If you have any questions, please put them in the chat. I will answer them as fast as I can. And if I can't answer them, I'll let you know and get back to you with an email. Okay, with that, daylighting. Where in the code book do we look for daylighting? Well, it's going to be in chapter 405, and it's going to be in the definitions. We need to start with the definitions. If you don't know the definition of a topic, it's kind of hard to understand what you're supposed to do with it. So, what is a daylight zone? Chapter 2 tells us that the daylight zone is that portion of a building's interior floor area that is illuminated by natural light. So what the heck is that? Well, that's the windows, folks. That's our skylights. If you have a crack in the wall, that would be considered daylighting, but then we have bigger issues. So any fenestration that allows light through it is what we're looking for as a daylight zone there. So we talked about skylights. We talked about fenestrations. What are skylights? Well, it's a light in the roof. That's what it is. It's a window in the roof. It's glass or other transparent or translucent glazing material installed at a slope of less than 60 degrees from horizontal. This includes unit skylights, our tubular daylighting, the solar tubes that we have going in, and glazing materials in solariums, sunrooms, greenhouses, and sloped walls. That's 60% there. The 60 degrees is really our key. That's what defines the definition of a skylight and keeps that from becoming a window. So 60 degrees or less. Vertical fenestrations, that's windows that are fixed or operable. Opaque doors, glazed block, and combination opaque and glazed doors composed of glass or other transparent or translucent material and installed on the slope that is not less than 60 degrees. In this, if you have an opaque door or an opaque window, um, those are not going to be able to give you our daylight zone. So it seems redundant, but I always bring that up because I have had that question from some contractors in the past and a designer who was putting in a very, very dark stained glass window. So that did not transfer light through. We called it opaque, and therefore we're not required to have that daylight zone. Let's take a look here and see what we've got going on. Looking at this picture, I'm going to get a little participation out of you guys this morning. Are these skylights or are these vertical fenestrations? What do you think? Toss it in the chat for me. Skylights, absolutely. What's the angle of the opening? Well, based on this picture, Carl, we're going to say it's less than 60 degrees. Great question, Carl. You do need to know that to make that work. What's this? Vertical fenestration? Skylight or windows. We can go with that. Okay, I like it. We've got vertical fenestrations going on here. So this one here, what do we think? Vertical or skylights? Okay, I need to come up with harder questions. You guys are nailing this. So here's a fun one. We've got a wall going up, and then we've got the roof. What do we have here? Absolutely correct. We do have both. We have that vertical fenestration right there. Let me get that little laser pointer out there that I love and hate so much. We've got our vertical fenestration right here on the wall. We've got our skylights up here. Let's keep on rocking. So, we do have some amended sections of the code. This comes straight out of the code literature. Chapter 4 of the commercial energy efficiency is to be followed from the IECC except as noted below. Section 402.4.2.1, lighting controls in top lit daylight zones, has been deleted. And then section 405.2.4.3, the top lit zone has been deleted. So what that means is if you look in the IECC and you hit those sections, they're going to tell you that you need to have daylighting uh, designated on the plans and controls for that. But with the amendments that we have here, that's not a requirement. So just want to get that up there. We'll touch base on it a couple times, make sure that we try to eliminate the confusion on that. The top lit controls and skylighting top lit zones just aren't there, so we can keep on running. A duplicate slide? How dare I do that? So, not only do we look in the code book for the definitions, but we're going to look at 103.2 for the information on our construction documents. As you know, as an energy inspector, as an energy plans examiner, thank you, Carl. As an energy inspector, as an energy plans examiner, love this section. This gives us everything we need for figuring out what's happening and going on with our plans and the information we have to have on those plans. Makes everyone's life easier, not only the building officials, the inspectors, and plans examiners, but also the contractors, because with that information there, there's no guesswork going on or limited guesswork. We can make changes, but we need to make sure it's all documented. So here, equipment system controls, item number 8. Item number 11, lighting fixture schedule and wattage and control narrative. That control narrative is huge for us on daylighting zones. We need to know where excuse me, we need to know where the daylighting sensors are at, how they're configured, how they're adjusted, and how they work with the rest of the lights in the room, as far as automatic sensors, timers, all of those good things that are required. And then we need to see the location of the daylight zones on the floor plans. This is huge for everybody. If we don't have those daylight zones on the floor plans, then we're just guessing. And it's really hard to configure those sensors for the daylight zones if we don't know how far out they're supposed to go and be active with. So these are the three items in the code that give us the requirements to what we need and to have on the plans. And like I said, trying to install these daylight zones and trying to inspect them without this information just can't happen. So if you don't have it on the plans, um, you're going to have to get it to be able to do those inspections. Chapter Section C 405.2.4, that's the third part of where we're looking for this on our daylight responsive controls. So when we go there, when are they not required? So daylight responsive controls are not required in healthcare facilities, ambulatory um, clinics, doctor's offices, dentist offices. We want to make sure that we're not going in the middle of a procedure and lights start dimming. that the folks doing that have the ability to complete their processes and their surgeries in a safe and well lit fashion. So it's not required in silent zones on the first floor above grade for A2 and M occupancies. Our assembly occupancies and our mercantile occupancies do not require that on the second floors and above. New, mil- New buildings that meet the adjustable interior lighting power allowance with equation 4.9. So if we're already meeting the adjustable lighting power, then we are don't need to be redundant with the daylighting zones. And then fenestration less than 24 feet square for side lights. So if it's under 24 square feet, we don't need to do that. One of the things we want to remember, the reason for the daylighting is that we're trying to help use the energy in the building the most efficiently way possible. So when we talk about that, it used to be with our incandescent lights. We were running 30, 40, maybe even 50% of our electrical energy was being run by the lights. We went to the LEDs, to the compact fluorescents, the halides. All of these are much more energy efficient. So how do we keep getting better on our energy efficiency with that? Well, when do we use it and how do we regulate it? One of the reasons why we use these daylight responsive controls is to make sure that the light's being used in a responsible fashion. So if you've got a wall of windows like we see over here, and we're getting sunlight because this points to the east in the morning, why in the world would we run lights on the inside for daylight burning to give us maybe a little bit more clarity when the natural light's doing it and we can get those shut down and use that natural lighting in there. And then as the sun goes over the top of the building, that light gets less, those lights turn on. So, when are the daylight zones required, responsive controls required? When we have more than 300 watts of energy in our areas. We have two zones in these areas. The sidelight zones are the primary and secondary zone. We can have rooftop monitors, top-lit zones, and atriums. These are all places where we need those controls. Sidelight zones, the primary zone is greater than and equal to 150 watts. I apologize. I said 300 watts before. Uh, my mistake. I was adding things together. It's the 150 watts for the primary zone. That's when that's required. So here we can see what we have happening. We have our floor plan here. We have a window right here. We have 150 watts of general lighting going on in the primary zone. Once we have that, then we have to have the daylight responsive controls installed. And then we have our secondary zone. We have a roof and a floor system. So this is our roof here, this is our floor, and this is where we're at. This is what it would look like on the floor plan. We have our wall right here going around the office area. We have a window. We have that primary daylight zone here with 150 watts general lighting, and then the secondary daylight zone. Do we have any questions on the pictures here as to how this works and what's happening? Okay. So again, the primary zone is greater than 150 watts. If we have a total of 300 watts in both zones, then we also require those responsive controls. So again, that was the 300 watts that I was talking about was for both the primary and secondary zone. The primary zone by itself, if you have that greater than or equal to 150, we're going to be looking for those controls to be put in place. So again, this is our window. This is our ceiling up here, our floor down here. We have the 150. So say we had 120 watts here. And over here, we had 180 watts. We had some extra lights put in. Those total of 300 watts. Now we require the daylight controls, responsive controls. I will get this, I promise. The responsive controls, again, our floor plan here, walls, walls, walls. We have the 300 in the total. Daylight responsive controls are required as well. So Paul has a question here. He says if there are windows with a high solar heat gain factor for cooling loads, do the controls take care of the light level? Yes, that's exactly what those responsive controls do, Paul. Again, we have sensors in the rooms that are calibrated for the amount of light that's coming in from the exterior, and that dims the lights inside that area to maintain the appropriate lighting. So that way we're not using as much energy. Great question, Paul. So the primary side lighted area, how do we get this? What's our calculation on it? And how do we make sure that it's correct on the plans? So what we're looking is the width of the vertical fenestration plus half the distance of the wall height of the window or to the full wall. So half the distance of the height of the window. Let's say that this window is at 6 feet tall right here. So from here to the top of the window, half of that height would be 3 foot. So that would be the width of the window plus the 3 feet. So that tells us how wide we're going to go there. The depth of the window is the distance of, or let me go back to the width. I apologize. If a designer wants to get more energy in there, if this wall was 8 foot tall, you could take that. So you would do half the width of this window. Let's say this is a 4 foot window here, 4 foot wide. So we would do the width of the window plus half the height here. So doing the full wall at 8 foot would be 4 foot. So from the center line here out, we would have 6 feet of window, the window itself, and 4 extra feet. If we do the window there with the window height, then we would add 3 feet to the window. So that would be a 5 foot there from the center line out, totaling up to a 10 foot or a 12 foot primary zone. Does that make sense to everybody? I think if I try, I could make it a little more confusing. Okay, so our secondary or depth of the primary side light, the distance of to the height of the vertical fenestration perpendicular to the fenestration. So this area is for the distance measured from the fenestration height perpendicular to the fenestration to where there is a full height wall. So our depth on this is measured from that perpendicular fenestration and comes out. We duplicate this all for the secondary side lighted area. zero point 0.5 plus the height plus the width plus 0.5 of the height of the wall gives us our area here. So we'll take a look at this example. The height of this window, the distance to the height of the vertical fenestration is 10 feet. So we measure 10 feet out. That's the depth of the primary side light. Then we're going to duplicate that for the second. Uh, so Francois got a question here. It says, can you point to the section of the IECC that explains skylight area calcs? It seems that the height of the it seems that the height of the glazing, not just the head height, should be a factor. What if I have a ribbon window, for example? So that ribbon window is taken to the height of the fenestration, just like this shows here, Francois. And that comes out of just a second here. Old school. I actually have the code book. That should be 405.2 mechanical electrical. Okay, so got these quick tabs and they aren't very quick at times. So with the ribbon windows, like I said, it comes right out of there. And we are looking in that 405.2.4.2 section, Francois. Okay. So on our floor plan view here, like I said, we have that 10-foot window. So if we go that, half of that height is an extended 5 feet. Then we have 5 foot here. So half that distance is added to each side. So the width of the window plus 10 feet and our 10 foot in depth comes all the way across out here for that primary zone. Thankfully, we didn't have to add any factors for the secondary zone. So this is truly just a duplication for that secondary daylight zone. This is important because this is what we're going to use for, again, those calculations for wattage. Do we have the 300 watts total in here, or do we have 150 in here? So we need to know what those daylight zones are and be able to check these on the plans to verify what's happening and whether or not those responsive controls are there. So let's take a look at this plan right here. We can see we've got some windows coming across, a door here. Across here, we've got the window across here. There's a window right there. There's a window right there. So we have duplicate daylight zones. What we're going to be doing is taking a look at the electricity in these zones here. Make sure that we're over the 300 watts or over the 150 watts, and that will make that determination as to what we have happening. You can see the secondary zone coming in here. So we took half this window height and came over here, added that up. So this is our primary zone. This is our secondary zone here. And then we would go to our lighting schedule to verify what's going on with the wattages. So let's take a look here. We've got a storefront operation here. We've got a door. We've got windows coming across. This whole thing is our daylight zone. Now, we have walls here, so we're not going to be able to add to that. Obviously, if the whole room's got windows across it, we don't need to add that into the other side. I've had some folks try to do that before, making life a little more difficult. You got a full opaque wall there, no need to make that change. We have our primary zone, our secondary zone. We are on the way. And we have a third zone here. Again, another storefront. This one doesn't have a door. So we would look at this from here and here and our secondary zone here. Now, every once in a while, I don't know why, I will get a storefront that has glazing across here and they'll put in an opaque door. Again, not sure why they would do that, but they do. So if that's the case, then we have to take our daylight zones for the window that's closest to that door, just like we would do over here. So just keep that in mind when you're out in the field looking at that, or when you're looking at it on the plans. Door schedules, window schedules are huge in what we're doing, and then we have to compare it with our electric lighting schedule. Any questions on this so far? So, our functions, now that we have decided and made the determination that we do need daylight responsive controls, we have to have a function for them and how they are worked. They have to be controlled independently from the primary and secondary zone. They have to be calibrated from within the space at a location of ready access. Now, this isn't an accessible situation. This is a situation where you can't put these controls where you have to stand on top of a ladder or scaffolding to get to. They have to be down at operational level, being able to readily access them so we can adjust them because they are mechanical electronic devices. Sometimes they get out of whack. If we have to put in a new sensor and recalibrate it and readjust it, we truly have to be able to get to it without climbing on top of a bucket. So we want to make sure that those are in accessible place. They have to dim continuously from full to a maximum of 15%. So not completely shut off, but 15% of the total light coming out is where they have to get to. They have to shut off all the controlled lights. So again, if we're in that primary zone and the secondary zone, and we have a light that goes in between. So if we go back here, we can see this light right here is in the primary and the secondary. So we have to make a decision as plans examiners as to which one of these is going to affect this the most. Is it the primary or the secondary? The way I've been taught to do this and the way I've done it is if you're in the primary zone, then that has to be controlled by the primary um, lighting sensor. So with this one, if these happen to be multiple lights, multiple lamps in here, then the lamps in the primary zone would be under that control. The other ones would be under the control of the secondary. But if this is one long fixture, one luminaire across here, then it's going to be controlled on the primary side. Occupant sensors reduce lighting in unoccupied areas per code with additional controls for light levels and power. So this is where that sequence of control comes in play. We have a occupant sensor in this room that tells us that someone has left. When they come back in, the lights come on. But we still have to maintain our daylighting controls here as well. So when those lights come back on, now that's going to be initiated by the occupant sensor. Then our daylighting controls are going to take over and say, hey, the sun's coming through here. We're getting suntans at our desk. We need to turn these lights down. That's the functions of the control, the sequence of controls on there that we need to have. We need to have those on the plan review, and we need to have those out in the field so we can verify that that's working when we're out there. So if we have zones that are facing different directions, they need to be independently controlled. Back here to this. So let's say over here we had another window coming in over here, and our primary zone came out to here like this, and then so if we had a window here and we had a zone, man, I cannot draw straight with the mouse. All of you architects and designers can laugh at me. Bring this over here and here. Here's our primary. Here's our secondary. So now we've got a situation where we have multiple controls going on. These lights here are now in the primary section over here for this zone. So this occupancy sensor or this daylight responsive sensor here would be in control of this as well as the secondary that's in control of this for this zone here. So it gets really fun when we have different zones overlapping each other. Does this make sense to everybody? Do I need to try to draw a little bit better? Okay. No one's throwing tomato emojis at me. We're going to keep on going. There are two exceptions for the controls. Up to 150 watts of primary zone can be controlled with another primary zone facing the different direction, and up to 150 watts of secondary zone can be controlled with another secondary zone facing different directions. So back here to our drawing, if this was only 150 watts across here from this original primary zone, and this light here was only 150 watts, we could actually do that control there for that. This one here would still have to be under control of this primary zone here for this window. Same with our secondary. If we were able to do that, we would be good. Obviously, over here, these two would be under the control of this one. Or if for some reason this was less than 150 watts, you could do the control here. So this is where we're going to have a lot of clarification with our designers, with the installers, and obviously with the sequence of operations and which control is controlling which light. Without that clarification, this gets really, really difficult. So here we go with this. I like the other one in the drawing because it gives me a chance to draw, but this shows us what we have going along in a little more clarity without the confusion of the lights. But I do like to show those lights because in a lot of our office buildings and especially mercantile, we end up with those long strip lights. We're not getting just the can lights or the small lighting fixtures that are pendulum fixtures hanging down. So with that, we need to be able to make that determination as to which one of those is control that light. So the side light zones, got to have them with the two primary, the rooftops, the top lit zones, and in the atriums. Daylight area under rooftop monitors. This is kind of what you were talking about, Francois. We've got some ribbon up here. So this is how we would look at that and where our requirements are for that daylight zone. The width of the vertical fenestration above the ceiling level, plus on each side the smallest of the nearest obstruction that is taller than 70% of the ceiling height, or 25% of the distance from the floor to the bottom of the fenestration. So our ceiling height here, our fenestration here, we could use 25% of that. If we had a wall that was coming in here and blocking that, then we would have that distance there because obviously it's not going to go through the wall. The horizontal distances are inward from the bottom edge of the fenestration to the nearest obstruction that is taller than 70% of the ceiling height, or the distance from the floor to the bottom of the fenestration. So again, if we had a wall in here that was over 70% tall, our daylight zone would go to that. With the depth of this not having that, then we're going to go the full depth from the distance of the floor to the bottom of the fenestration. That's going to come out here and give us those top lit zones. Excuse me, the roof monitor zones, not top lit zones. Top lit zones are only for skylights. I apologize, folks. Didn't mean to throw that term in there. This is the roof monitors. So here you can see a section where we have that rooftop monitor right here. We have the height, which is the daylight zone, comes here for the height of the ceiling, stretches out to here. We have an obstruction that's over 70% of the wall, so the daylight zone would come up to here. When we look at that on the floor plan, we still have to do the 25% of the height on each side of that set of monitors or those windows up there. and then continue out. The obstruction here can come in, but if that obstruction doesn't come all the way across the daylight zone, then that daylight zone extends out. Just a little bit of common sense there for those rooftop monitors. Again, we have to have the primary and secondary zones calibrated independently. Got to be in an accessible space. Got to go down to 15%. Has to work with our occupant sensors and all of our other requirements for the lighting controls. If we have the independently faced monitor directions, then they have to be controlled independently. And then again, we're back to our two exceptions for the controls. If we have the 150 watts can be controlled by either one. So this is the same as what we have going on with the regular windows. This all clears the window for everybody so far? Side light zones for top lit. So we throw this in here to say that it is in the code book, but it has been taken out of the requirements by the New Mexico code. So this would be what we would be looking at for those top lit zones and how to figure them out. If you want to put these in, you can, and this would be the way to do that. But there is no requirement in the code that these be there. So just want to let you know how to work it and where it's at. So it's zero point 0.7 of the ceiling height for our top lit zones. You can see over here what's going on and how we get that number. It's 70% in each direction from the skylight, and it's perpendicular to the skylight. So if we have an octagonal or a triangular skylight up there, we would take those off of those angles perpendicular to it. The daylight area is zero point 0.5 of the ceiling height because of an obstruction. So we would keep going with what that has happened. These are the same. We have to have them independently side lit, controlled. They have to be calibrated from in the space of ready access. So this one's another one where I've had folks say, hey, this is a top lit zone. My sensor's up here on the ceiling. I need to put the controls up here. That's incorrect. They do need to be in that accessible location. We need to have the order of operations as to how they're all working and what's happening with them. So let's jump to atriums next. So daylight zones are at the top floor and at the floor. We do not apply the daylight zones to the rest of these. So if we have windows that come across and around, each one of these floors, if they had windows, they would be addressed separately that way. But the atrium responsive requirements are only for the top floor and the bottom floor. So it's 0.7 of the ceiling height from the outside of the finish, the top lit zone, and on each side coming down for the full height of the top floor. And it's the same down here on the bottom floor. It's 0.7 of the ceiling height. That 0.7 is based upon the top floor ceiling height, not the bottom floor. So if you have an extended bottom floor down here, we're going to use this number up here. So on this, the multi-story spaces, 70% of the ceiling height measured in each direction from the skylight. Remember I said with triangular, we're going to take it this way, we're going to take it this way, we're going to take it that way. So it's perpendicular off of those. Thank you, Carl. Have a great day, sir. Here we've got the distance to the nearest opaque vertical obstruction. So we're going to take this out here. We hit this wall here. Obviously, we're not going to continue through that. The light's not going to go through there. The bottom floor of the building are areas in direct contact with the skylight. Again, if we have a wall that's there, it doesn't count past that if our calculations say it should. With these, gets a little redundant, but it's the same thing. We need to make sure that they're calibrated from the space at ready access location. Now, this one it can be a little bit interesting with the atriums because the calibration could be on the top floor, or you could put it on the bottom floor where it's inside that daylight zone. So you need to make sure that it's somewhere that can be reached, and again, not have to crawl across stuff or build anything to get to it. We need to know our order of operations. It has to control all of the lights, and it has to get down to at least 15% of the energy usage or light production. We've done our definitions. We've done the information on the construction documents. We've beat up on our daylight responsive controls. Increased vertical fenestration area with daylight responsive controls. C 402.4.1.1. The code allows for 30% windows to wall ratio for the prescriptive path. We can go up to 40% if all of the following things happen. The building is 2 stories or less. 50% of the net floor area is in a daylight zone. If the building's 3 stories or more, then daylight responsive controls are installed in all daylight zones, and the visible transmittance of vertical fenestration is 1.1 times the solar heat gain coefficient. So we got a little bit of math there to be able to increase this, but we can increase the allowable window and fenestration totals to 40% if we have that meet those requirements. Minimum skylight fenestration area 402.4.2. In certain occupancies, we're allowed 2,500 square feet, 75% of the roof if it has a minimum height of 15 feet. Offices, lobbies, atriums, concourses, corridors, garages, service garages, storage space, non-refrigerated warehouses. That's a fun one. I've had a lot of folks try to put a bunch of skylights in the refrigerated warehouses. That just seems like a bad idea to me. Distribution areas, transportation depots, and workshops. So the total split area must be a minimum of 50% of the floor area. Pick one of the following, a minimum of 3%, and we have to meet the requirements of the equation 4 in 402.4.2. So even though we took the responsive controls out, if you have them, you can make that work. So here we have this. We can increase the skylight area by up to 6% if daylight controls are installed in the top lit zones. Again, can't reiterate this enough. They're not required by the code in New Mexico. Don't need to have them. But if you decide to put them in and go above code, then you can absolutely increase your skylight area by 6%. Give you more natural light. The minimum and maximum area of fenestration is required by the code. Windows and skylights create our daylight zones. Pretty obvious there. Daylight zones must be documented on the plans, and daylight controls may be required. So, with again, we need to know where those zones are and what's happening. So, any questions so far? Okay, well, I've got a question for you. Taking a look at this picture, this, I will tell you, is the inside of a church steeple. Based on what we've learned today, would we require daylight controls based on this picture? Now, I know that seems like an ambiguous question, but think about everything that's required for them and tell me what you think. All right, we've got a couple no's going on here. Um, if you answer no or if you answer yes, let us know why as well. What makes you think, Brian and John, that they're not required to have daylight controls in here? What's the reason we don't need them? Too high. Okay. Yep. That that's unoccupied space. Good answer. So the simple one on this, then those could all be factors. We'd need a little more information on that. Um, as far as the too high, we go back to these being almost a roof monitor situation, so we'd have to work with those there, Paul. But the unoccupied space could definitely be a portion of it. What I look at is there are no lights in here. We don't have our 300 watts of lighting. We don't need to worry about daylight controls. That one, like I said, it's a little tricky on this one, but I thought it was a great picture. Found this one in, of all places, a little town out in Kansas. It was a very interesting job site to go to. Um, this is a corrugated steel roof, and it has no insulation on it. So, as an energy person, I had a little bit of heart palpitations on different items, but the lighting controls were not one of them. Thank you, everybody. It's a chimney. I like it. Uh, let's take a look at another one here. So, would we require lighting controls in this apartment complex, saying this is on the fifth floor of the building? Give a little background on this one's fifth floor of the building. Do they require lighting controls for our lights in here? We're also going to say that they have 450 watts of energy going on inside of 5 feet of the window. We have some very high can lights going on in here and also up here. Do we need to have daylight responsive controls on this? Absolutely. You are correct. The answer is yes. Because we have the wattage going in here that's um, over the 150 for the primary zone and over the 300 for the secondary at 450, we would definitely need it. Where it becomes interesting is because we have these monitors up here. The second part of this question, which I'll answer, is do we need to have two sets of daylight zones? Because we have this here's all under control, so that's a ceiling height there for those primary zones coming out here. Yes, that is correct. We would need two different daylight zones because of these upper monitor windows. Another tricky one, and this is one that on plans, I can say I made this mistake. I required only one daylight zone, and my supervisor came back to me after the inspector caught it out in the field and asked me what I was thinking. And I had totally missed the ceiling right here, and I was basing everything off of the monitor zones up here. So just trying to keep folks from doing some of the mistakes I've done. So here's one. In New Mexico, would this require daylight responsive controls? Now, this is a wall going up. So you have a wall going up to a skylight with a glass wall there. Do we need to have daylight responsive in here with these two meeting like that? That's correct. On the vertical face, yes, we do need that. So this is another one. We see this a lot in greenhouses, solariums. This one was actually a project out in Golden that was being done for a manufacturing company, and this was their office. But yes, we do need to have this here in New Mexico because of our vertical fenestration. That is an absolute requirement for the daylight responsive controls. Okay, I know I went through that in a, pretty big hurry. If you have any questions, put them in the chat. Give a holler there. We also have the New Mexico helpline here. We're here to help you on anything that you have questions about the code, plan review, inspections, design. We can help contractors. You name it, we can do it. Send us the emails. The whole staff is waiting to help out. We'll get back to you and let you know what we think of your questions and how we are looking at them. Give you an interpretation and let you know where it's at. On here, this is the Shums Coda site. On this site, you can go there with the QR code. I also posted that website on the chat, very first thing. Come down here to the New Mexico Energy Code Support Program. That will take you to this page here. On here, we have our documents that we've been putting out there for New Mexico, all of our technical documents. We also have the YouTube channel on here so you can see some of the past classes. It does take us a while to get those up to date, but we do put them on there so you can go back and look at this one again if you have questions on daylighting. Hopefully, this will be able to help you. You can also get there from this QR code. And also on here, we have the New Mexico helpline. One-stop shopping for everything we can do to help out. So, coming up next week, we're going to be doing the inspections for commercial lighting, and then we're going to jump to the plan review for mechanical. These are what's coming up in the future for the weekly classes. So, look forward to seeing you all there. And finally, our survey. Let us know what you thought of today's program, folks. If the class was good, let us know. If there's something we can do better, please put it on there. And also, if you have any ideas for other classes, we truly appreciate it. I'm a little bit early today, folks, but I want to say thank you so much for being here. Appreciate everybody and everything. Appreciate all the interactions. Have a great day. I'm going to stick around for a couple minutes in case there's any last questions. Appreciate it, everybody. Thank you so much. I hope you have a great day. Okay, folks. Good to have everybody on here. Enjoy your day. Like I said, I'm going to go ahead and shut the program down. Thank you so much.